Welcome to the 14th lecture of Logic and Distributed Control System. So today we are going to understand the PLC number comparison functions and using this how to develop several ladder logic. The objectives are that at the end of this chapter you will able to list and define the 6 basic compare functions, apply each of the basic compare functions to application processes, describe advanced compare functions and their use, apply combination of compare functions to do multiple comparison analysis. So as an introduction, medium and large PLCs have number comparison capabilities. The number comparisons are performed internally in a manner similar to microcomputers and microprocessors. With the PLC, there is no internal programming necessary for the operator. The PLC programming is set up for direct keyboard and screen arithmetic logic. This chapter illustrates how to perform number comparisons of all types of PLC programming. PLC basic comparison functions. Many PLCs have only 2 compare functions. They are equal and greater than equal to. To perform any one of the other 4 functions like not equal, less than, greater than, and less than or equal to, combinations of the basic 2 are used. It means that if we have the equal and greater than or equal to, then other 4 functions can be realized using these 2 compare functions. Some PLCs have all 6 individual functions, which makes programming easier. This chapter uses the PLC comparison system with 2 basic functions for illustration. So here we will use only equal and greater than equal to. Other 4 we will realize using these 2 basic compare functions, that is equal and greater than equal to. The other 4 PLC compare functions, as I said, are the inverse or the combinations of the 2 basic functions. Figure shows a table comparison function. So now let us see what are the comparison functions we have. We have the equal, not equal, greater than or equal to, less than, greater than, and less than or equal to. In between these 6 compare functions, as I said that star mark is given, you will find that the number 1 and the number 3, they are the basic comparison functions, that is A equal to B, and suppose A and B, 2 are the 2 numbers we are going to compare. If A equal to B, then the equal functions are going to be energized. I will show you the block format. Here only the circuit that is conducts when equation is true, fine. And the direct functions, it is that is EQE, okay, it will be used to indicate the equal function. If it is not equal, you see we can use without using the separate function for the not equal to, we can use the reverse logic of equal, then we can use the not equal, and then greater than equal to, that is indicated by GE. And if we want to perform the less than, strictly less than, then it will be not of greater than equal to. And if it is greater than, then A greater than B, then obviously it will be greater than but not equal to, okay, greater than but not equal to. So that's why G and EQ as a normally closed. Then less than or equal to, so it is less than or, so then less than or equal to, you can see that less than means not greater than, so and or equal to, so as a or equal to is used. So you see, using only the G and EQ, we can perform other 4 basic compare functions. So here in this lecture also you will find that we are not going to use the other 4 functions like not equal, less than, greater than, or less than or equal to separately. We will realize these functions or these compare functions using 2 basic functions, that is equal and greater than or equal to, fine. So now as an example, when we are going to compare, then how the comparison is going to be done. Assume that A, the standard for the comparison, is placed in the operand 2 and A is set at 182. Fine. So you will find that definitely in the block format you will find that two registers will be there, one registers for the operand 1 and another registers for the operand 2. So let us, the operand 2 is the A number and A is set at 182. Then B, the number to be compared to A, will be placed in the operand 1. Fine. So this is, you can assume that so this is the A, so operand 2 and the number so which is set as 182. Now we are going to compare with the B, okay, and we are therefore comparing the value of B to the value of A, that is 182. So that's why when it will be equal, when B when equal will be true only if the B is exactly 182. Fine. And not equal then if B is 181 or less, or B is 183 or more, then not equal will be true. Then greater than or equal to, greater than or equal to is true only when B is 182 or less, because we are comparing with A. Fine. So the number what will come at the B, if the greater than equal to is true only when B is 182 or less, means A must be greater than B. And then less than is true only when B is 183 or more, and then greater than is true is only when B is 181 or less, and less than or equal to is true only when the less than or equal to will be true only when the B is 182 or more. So in this way the comparison functions are going to be performed. Fine. So in actual operation, A might be, this A might be a varying number, not a fixed value of 182. Means it may be a register content also which has to be read. It may not be the constant, but it may be a address of the register. So then programming format. So in figure we show the three typical programming formats, and obviously the most useful format will be the block format, which is shown here. You see the block format here, you can see that enable line is there, IN71, and the operand 2 and operand 1 will be there, and we have to prefix for the function. But I want to tell you that here only we are going to use two functions to realize other functions. So you have to use EQ. If you write EQ 80081, so we are going to perform the equal function, okay, means as I said you that here actually it is what we have discussed, it is in a reversed way it has been shown. So suppose this is the operand A and this is the operand B, okay. So if it is 182 and B is exactly 182, then this equal 81, that particular coil is going to be energized. Fine. So then another function, as I told you, that we are going to use only the GEQ, greater than equal to. So if it is suppose GEQ, okay, GEQ 81, fine. So when the B is 181 or less, then your GEQ 81 is going to be energized. Here what it is mentioned, okay, greater than or equal to, you can see that greater than yes, greater than or equal to is true only when B is 182 or less. Fine. Other two formats are there. I'm not going to discuss that one. You can read that one. That is the coil format. So this is as simple as before what we have discussed about the different arithmetic function. Okay. So now, as I said that the two numbers being compared are operand 1 and operand 2. One operand can be a constant and other is a register. Both operands may also be the registers that contain numerical value. The identification number of the register should be specified in the functional block. When the function is enabled by the input contact, the comparison is made. If the comparison is true, the output goes on. If the comparison is false, the output goes off or stays off. The comparison in some PLC is made continuously as long as the enable is on. It makes the comparison on each scan. So if you make this IN71 close, then each scan the comparison will be done and the result will be reflected by the coil 81. And in some other PLCs, the comparison is made only at the time of the enable goes on. To make other numerical comparison, the input must go off and then back on. Fine. So now one by one comparison function we will discuss using example. So one example now we are going to understand, where we will see that in between this operand 1 and operand 2, one of the register is constant. One value is constant. Fine. So let us discuss that one. That is example 1. We use the equal to compare functions. We are bending dowels. Dowels means, suppose it is a stick. So bending dowels into bundles of 40. So 40 sticks has to be packed. A counter function keeps track of the count of number of dowels in the bundle. As they are added, the dowel count number is kept in HR005. Okay, the running count is compared to 40. So when the count reaches 40, the comparison is true. The output CR19 goes on, and the output CR19 is connected to a bander that operates when the 40 is reached. Bander means then one girder will be there such that 40 dowels will be bundled. Okay, the bundle removal and reset systems are not shown. The count in HR005 must be in the correct numbering system. We are comparing with a decimal 40. So here you see, here it is mentioned that the count number is kept at HR005 and the running count is compared to 40. So when the count is just 40, so another register you have to take for the operand 2 where the 40 has to be stored. Here the half of the program actually it has been shown. Here you can observe that IN001 we have taken an operand 1 for the compare functions. Okay, that suppose EQ we have taken. So here better, as I said earlier, you should mention only EQ19. Okay, and with this you can actually use another contact to suppose you have to make a binding with the 40 bundles. So you can write here EQ19 and that operation particular, that whenever the operand 2 will be equal to the operand 1, then equal 19 is going to be energized, means this is going to close, and then CR19 is going to be energized. Okay, but here half of the program has been shown. Actually the counter has not been shown. So in your exam you have to show the counter. Means here what I want to mean that actually this address of operand 1 is very important. That is the address of the accumulator of the counter. How? Now here you can use the count. Okay, so that may be IN02 and another is enable, and here you can use the counter. Okay, and for the counter, this register, that is the accumulator register, will be 05 and preset PRE, and preset you can say that preset value will be here the 40 counts are there, so it will be 40. Okay, so now here you can have the that is up counter, suppose 01. Okay, now what will happen? So this is your count and this is your reset or enable. Fine, suppose it is IN03. Now so both are energized, both are on. So now what will happen? Whenever there is a 40 number of pulse has been received, then this UC01 will be energized and the content of HR05 will be equal to 40. Okay, and here that that 40 has to be 40 is going to be reflected HR05, and whenever the HR05 is going to be 40, then it is going to be equal with the operand 2, and then the EQ19 is going to be energized. Okay, so in this way the equal function is going to work. Fine. So here that is shown. The count in HR005 must be in the correct numbering system. We are comparing to a decimal 40, so HR005 must be in decimal for proper operation. Some PLCs convert the proper numbering system automatically and some do not. Appropriate number conversion may be needed. Okay. So this is the way, and here you can see that operand 2 we have kept constant. Operand 2 we have kept constant, that is 40. It can happen that the operand 2 will be the address of the registers, and that particular count is coming from somewhere. So then we are going to discuss that kind of situation. So use of equal to compare functions in a different situation. Another equal to application is shown in the figure. In this case, an output must go on when two numbers are equal. The numbers values do not matter except they are equal. Means whenever the operand 2, that is HR123, will be equal to the HR147, then the equal function is going to be energized. Okay, the two numbers to be compared are fed from outside processes into HR123 and HR147. So you can assume that suppose you have a situation that suppose you have that example of conveyor belt where you have the two paths. Okay, so here suppose one sensor is going to be placed and here another sensor is going to be placed, and whenever suppose this is the counter A and this is the counter B, and thing is that whenever the number of counts in A and B will be same, then your suppose that one that is that equal is going to be energized. So whatever the counter you are using to count in the path A, the accumulator address will be HR23, and for the counter B, the accumulator address will be HR147. So whenever the count value at path A and whenever the count value at path B will be equal, then your equal that is EQ101 is going to be energized. Okay, so this way we can realize the or you can use the equal to compare function. Fine. Even now we are going to understand use of not equal. When we are going to use this, or what is the situation, how we are going to use a not equal, but we want to realize this not equal using equal. Okay. So in the example, the output is to be on except when an input count is exactly 87. Okay, so then what we have done, so here you see two things we have shown, direct function as well as the derived function, but not to use the direct function, we will use the derived function. Derived function means we will use the equal, and we want to realize the not equal. So now thing is that whenever the operand 1 is address is IR62 will be equal to the operand 2 which is 87. Okay, then except that case the output should be energized. So output here actually CR23. So now you see if it is on, okay, then here we are using equal function which is CR22, and CR22 is used as a normally closed here. Okay, so whenever the operand 1 is not equal to the operand 2, then this CR22 is not going to be energized. If it is not going to be energized, always this CR23 is going to be on, not equal indicator. Okay, whenever this operand 1 will be exactly equal to 87, then equal function means the CR22 is going to be energized. If it is going to be energized, then this in this rung the CR22 is going to be false, means CR23 is going to be off, means it is going to CR23 is exactly working as a not equal. So except equal to 87, your 23 will be on. Whenever the 87 is equal to the operand 1, then the 23 is going to off. Okay, so in this way we can use the not equal, or we can realize the not equal to compare function using equal function. Okay, then we have the direct use of greater than or equal to compare function. Okay, suppose in a situation an automatic pill bottle filling operation has to be done, and it having two possible bottle sizes. One bottle is to be filled to a count of 225 or more, the other have to be 475 or more. The figure shows the PLC function to control the pill count. So now suppose if we want to one by one, if we want to make the pill count 475 or more, then we will place that value in the operand 2, that is HR 182, that may be 225 or that may be 475, and the operand 1, that is IR 142, that will be the accumulator registers of the counter. Here also the part of the program has been shown, the counter has not been shown. Okay, so this operand 1 IR 142 will be the address of the accumulator of the counter. So whenever the 142 is going to receive the counts 1, that is 475 or 225 or more than that, then this GE function greater than equal to is going to be energized. So this is the way the greater than or equal to compare function is going to work. So as the bottle starts filling, enable is continuously pulsed, the comparison is untrue, and the output CR30 is off. Okay, so as long as the content of the IR 142 is not greater than or equal to the 475, then still then the CR30 is not going to be energized. So once the pill counts reach 225 for small bottle, CR30 goes on, and output CR30 is to connected, suppose a cap and remove operation, which is not shown here. The same sequence would be carried out for the large bottle with the HR 128 to set as a 475. Okay, so now use the less than compare function. So now if we want to use the less than compare function, how we can do that one? So suppose one situation we are considering, that is completed assemblies flow off of a production line as illustrated in figure. Okay, if an assembly is removed for the rework somewhere along the line, the part to be reworked is automatically counted. If there are more than 19 assemblies removed in an hour, a light in the foreman's office is to be turned off. If there are fewer than 19 rejects per hour, the light will remain on. Okay, so if there are more than 19 assemblies removed for an hour, a light in the foreman's office is to be turned off. If there are fewer than 19, then light must remain on. So how we can realize that one? We will see the derived functions. Okay, using greater than equal to, how we can do. So now you see the operand 2 we have kept 19. Okay, so if suppose if it is greater than equal to, if we are using the greater than equal to, so now suppose if it is 18. Okay, if it is 18, then this GE is going to be de-energized. If it is de-energized, then this output is going to be on. So that is the condition. Means if it is fewer than 19, then the light will remain on. Okay, and suppose if it is exactly 19 or greater than 19, then what will happen? This GE is going to be on, and if it is G is going to be on, then CR32 is going to be off, means the output, means the green light is going to be off. So in this way we use the greater than equal to function, greater than or equal to function, we can realize the less than, strictly less than function. Okay, so this is the use of less than compare function. Then example 5, use of the greater than compare function, strictly greater than. Okay, so then one situation will be created like this: the production operation requires a count greater than 348, the output to turn on. Exactly when it is greater than 348, then it is turned on. Okay, two comparison functions are required to derive the this derive function method greater than. Okay, so now here you see how we are going to perform that one. So we are using two logic, that is a greater than and equal to. Fine. And now you notice that the operand 1 HR11 and the operand 1 of the HR11 for the G greater than and the operand 1 for the greater than equal to are same, that is HR11. Okay, and the operand 2 is also same. Operand 2 is also same for both the cases, but this line is very important to realize the greater than function. Here CR20 is used as a normally open and CR22 is used as a normally closed. Okay, so now try to understand that HR12 has to be that is 348. Okay, and then here also it will be 348. Okay, now what is the condition? If it is only greater than 348, this indicator is should be on. So let us assume that we have the operand 1 347. Okay, here it is. You see, if HR11 is 347, then what is going to happen? If it is 347, then this is not going to be energized. CR21, if CR21 is not going to be energized, then this is in this line it is going to be off, means the indicator is going to be off. Fine, because at that time CR22 is also off because it is equal function. So 347 is not equal to 348, so it will be normally closed as it is. But if it is open, so that's why CR23 is not going to be energized. Now suppose it is 348 exactly. Okay, if it is 348, means operand 1 is 348 exactly. If it is 348, so greater than equal to, so this will be energized. So if this is energized, then this is going to be closed. But at that time CR22 is going to be energized, but it is going to be off in this rung. If it is off, at that condition also the indicator is not going to glow. Okay, so that's why whenever 348 is exactly matching with the operand 2, CR21 is off, CR22 is on, and then CR23 is off, still off. Now what will happen if it is 349, which is greater than 348? Then what will happen? G is going to be on. If G is going to be energized, then CR20 is going to be on. Okay, and in the equal function, what will happen? It is not equal, so that's why equal function will be de-energized. If it is CR20 is de-energized, it will be normally closed. So what will happen? At that condition, CR23 is going to on. So in this way, we can use the two functions through basic function greater than or equal to and equal to function to realize the strictly greater than function. Okay, so this is the way we can use the greater than function using the equal and greater than or equal to. Fine. Now we will see the use of less than or equal to. Okay, so a production system produces product that can be one of the three colors, red, white and blue. Fine. Some products they having three colors, red, white or blue. The production is limited to 348 blue units per day. Okay, 348 blue units per day. The blue units are counted by using a color sensitive detector. The detector count is fed to a PLC into HR11. The maximum desired count is 348 is inserted into HR12. Okay, so count, whatever the count value is given HR11 and the desired count, that is 348. So we want to produce the less than equal to, means not more than 348, only less than 348 we want to produce. Okay, so we want to stop something maybe. Okay, so let us how we can realize this less than or equal to using greater than and equal. Okay, so let us see here how we are doing that. On same way we are using greater than and equal whose coils are indicated by CR21 and CR22. Okay, now operand 1 operand 12 will contain the 348, definitely 348, and then we want that CR23 is going to be energized only if it is 348 or it is 347 and less than that. Okay, so this is the condition. Now let us see what will happen. So now first we are considering that 347 or less. So if it is 347, suppose HR11 where the counting value is coming, so that contains 347. Okay, so this contains 347. If it is 347, then what will happen to the greater than or equal to? It is not going to be energized. If it is not going to be energized, it will be normally closed as it is. Now what will happen to the equal function? Okay, the equal function also will be off. If it is off, then it is open. EQ22 is open, but for the operation we have make IN001 closed. So if it is closed, then what will happen? The CR23 is on. Okay, we want that one. So now what will happen if it is exactly 348? Okay, if it is exactly 340, that is HR11, if the HR11 is exactly 348, then GE21 it is greater than or equal to. Okay, so then GE1 means GE. Yes, so what will happen? CR21 is at that time it will be off. Okay, if it is exactly 348, and then the equal function, that CR22, okay, CR22 is going to be on. Fine. So if it is on, then what will happen? In that case also CR23 is going to be energized, because you see, whenever the 348 it is the operand 1, actually the CR21 in this logic it will be on. If it is on, here it is going to be off. If it is off, then from this line the CR23 is going to be energized. So that's why in this condition also 348 means but if it is greater than 349, then still this is going to be on, means CR21 is on. If it is on, then what will happen? Then CR21 is on, and if it is CR21 is on and the CR22 is off, okay, CR22 is off, then what will happen? That this CR21 is going to be false here, and the CR22 also going to be false here. Even if the IN0010 is closed, so CR23 is going to be off. Okay, so in this way we can realize the less than equal to function. Okay, so the indicator is on for counts below 348. When the count reaches 348, G stays off, EQ comes on, the output remains on. When the count goes up or one more to 349, the EQ goes off, indicating that the production limit for blue has been reached. The output is now off and the remain off for the higher counts. Okay, so that was our objective. Now for the multiple comparison, how we will do. So now for the example 7, this example for lighting an indicator only when the count is in between 15 and 22. Okay, so if this is the problem, that the one light has to glow when the count is between 15 and 22. So we will use two comparison function, that is greater than greater than equal to, greater than or equal to functions. And now interestingly here, actually in the operand 2 we will set it 15. Okay, what is our aim? Aim is that here that the count is in between 15 and 22. So count is in between 15 and 22, then only your output is going to be energized. Okay, so now here you see here the operand 2 for the greater than or equal to we have taken 15, and for the operand 2 for the another greater than equal to we have taken 23, means 22 plus 1. Okay, now that we have taken the enable IN16, then CR17 normally close, and CR18 we have taken, that is normally open CR17 and CR18 as a normally closed. Okay, now we will verify that for the cases. Okay, now suppose your count is 14. Okay, what will happen? So if it is 14, then CR17 is off. So now this is enabled, and if these are enabled, this is also enabled. If it is off for the 14, okay, then the light is not going to be energized. Okay, now if it is 15, okay, if it is 15, now suppose operand 1 is 15, so 15 will be here. Okay, it is 15, and this is also will be equal to 15. If these are 15, then what will happen to the GE? Means CR17. So the CR17 is going to be on. If it is on, then it is going to be it is going to be closed, and still the CR18 is off. If it is off, it is true here, then the indicator is going to glow. Okay, and now you can see that it is 15, 16, 17, 18, 19, 20, 21, 22, nothing is going to happen. Okay, nothing is going to happen means same condition, that 17 is going to be energized and the CR18 is de-energized, means still it is true, the output indicator is going to glow. But whenever the 23 we are reaching, then the CR17 is true. Fine, but at that moment of time CR18 is going to be false, means it is making the output CR19 off. So in this way we can realize this logic, that if the count in between 15 to 22, the light is going to be on. Okay, we using 2 greater than equal to function we can realize this. Another example we will discuss today, that is, this problem shows how compare function might be used in industry. A conveyor is supposed to have exactly 45 parts on it. We have 3 indicating lights to indicate the conveyor count status: less than 45 yellow, okay, less than 45 yellow, exactly 45 green, and more than 45 red. The count of parts on the conveyor is set at 45 each morning by an actual count of parts. There are 2 sensors on the conveyor. One is actuated by parts entering the conveyor and other is actuated by parts leaving. So already this problem we have indicated in the counter functions, that how to count the number of items on a conveyor belt using up counter and down counter. Okay, so now with that we have to use the compare function to do this operation, that is less than 45. So it is, if it is less than 45 count, so count is less than 45, then yellow, count is equal to 45, that is green, and the count is greater than 45, then we have to make red. Okay, so let us develop the programming here. Here you see 2 counter we have taken. One is up counter and one is down counter. Okay, and here the preset value, it is 45, it will be 45 actually. So to have the exact count, so HR101 have the exact count of 45. Okay, exact count of 45. So now what will happen, that if the count is less than 45, okay, if the count is less than 45, then what will happen that you are finding that here we are using two logic basically. Okay, equal, actually here for the equal 11, again one line I am going to draw, okay, which actually green, which actually green, equal, okay, green, that is equal 11. Fine, equal 11. Now what will happen if the count is less than 45? Okay, if less than 45, then the HR101 for the equal and greater than or equal to HR001 having a count less than 45. So suppose it is 44. Okay, if it is 44, so if it is 44, then this is equal 11 is not going to glow, means the green light is not glowing. Okay, and also this G12 is also off. If the G12 is also off, then you see we have used GCR12 as a normally closed, then the yellow light is going to glow. But what will happen to the red light? Red light is also not going to glow because it depends on the CR12, it is off. Okay, now suppose the exact count we got 45. Okay, count is 45, then what will happen? This equal 11 is going to glow, means going to be energized. If it is going to be energized, then this is going to be closed, means at that time green light is going to glow. What happened to the yellow light? At that time you will find that CR12 is already energized because it is greater than equal to. So if it is energized, yellow is going to off. Okay, because it is normally closed. And here you see we are using so CR12 is already energized, so it is going to be closed. But at that moment of time when it is reached to 45, equal 11 is going to be off. So if it is off, then this it is means in this rung the CR11 is going to be de-energized, means this red light is going to be off. Now if the count is greater than 45, what is going to happen? If the count is greater than 45, then this equal 11 is de-energized. If it is de-energized, so this is true. Okay, if this is true, then what will happen to the G12? Because still G12 is energized because its count is greater than 45. So if it is true, and if it is true, then the red light is going to glow. So this is the way we can develop the ladder diagram, what the problem has been stated here. Okay, so some of the advanced comparison functions are there, that is limit test, mask compare equal to, and compare expression. So these things I am leaving to you to study, and I will end here the lecture. Thank you.